4 million results pop up instantly. You'll see books like The Ultimate Carbohydrate Counter and The Ultimate Low Carb Diet Cookbook, and the entire series of books by Dr. Atkins. So, is this accurate? Have our traditional guidelines to eat high carbohydrate levels been completely misguided? Or worse, harmful? Maybe carbs are to blame for the now 2.1 billion people, and that is 30% of the world, that are obese. The short answer is that carbohydrates, particularly sugary desserts, sodas, and even sports drinks, cause dramatic changes to your hormones and can prime your body to store fat. These foods have what we call added sugars. If you didn't know it, sugar is one form of carbohydrate. And added sugars means that sugar was added in the preparation of the food. And this is different from the sugar that is naturally in the food. It is a difference between sugars in a candy bar compared to the sugar you would find in fruit. Most people don't think they eat many added sugars. The trouble is, sugars are hidden in many of the foods we eat, like candy, crackers, many boxed goods, because sugar provides a flavor that most people like. In fact, most of the foods we eat are prepackaged. They have sugars. To find out, just have a look at the nutrition label, and you'll be able to see a section called sugars. This is most likely from added sugars. Added sugars have been shown to increase inflammation in our vascular system and are linked with diabetes, and are recently shown to increase your risk of death from cardiovascular disease. So, how much added sugar is acceptable? Well, unfortunately, the current recommendations vary a lot. The Institute of Medicine recommends that less than 25% of your total calorie intake come from added sugars. But the World Health Organization recently lowered their recommendation of added sugars from less than 10% to less than 5% of total daily calorie intake. In real life, it can be hard to determine how much this actually is in terms of real food. For example, the American Heart Association recommends less than 100 calories or 25 grams of added sugar for women and less than 150 calories or 38 grams of added sugar for men. Considering that 1 teaspoon is equal to roughly 4 grams of sugar, a woman would be able to afford about 6 teaspoons of added sugar, and a man can eat about 9 teaspoons of added sugar. Just to illustrate, 12 ounces of one popular soda has about 39 grams of sugar, or just over 9 teaspoons. This exceeds the highest recommendation for the entire day for men and women. Does this seem like a lot? Well, it is, but some people use the same amount of added sugar just in their morning coffee. Also, if you look at the labels for any packaged foods you eat, this number of added sugar will quickly rise above recommended values. And keep this in mind, the recommended value is given just to avoid major health issues. It certainly is not about how to look and feel your best. Another tricky part about this part of nutrition is that sugar can hide very well. It goes by many other names such as cane syrup, molasses, sucrose, maltodextrin, and others. If you see multiple names of sugars like these on a food label, you might want to think about another choice. You can also look for food labels that say no added sugar. Believe it or not, over 70% of U.S. adults take in more than 10% of their daily calories from added sugar, from things like boxed goods, baked items, cereals, and sodas. Luckily, there are some easy ways to minimize your intake of added sugar. And one of the easiest changes to make is simply to avoid drinking excess sugar. If you can avoid sugary sodas, juices, and energy drinks, you can easily save a ton of added sugar and added calories. So, you might ask yourself what types of carbohydrates exist. Well, carbohydrates include things like fruit, pasta, whole grains, corn, peas, and breads. But do they all have the same impact on our bodies? For example, is fruit considered a carbohydrate just like pasta? Do candy bars affect us the same way as a bowl of oatmeal or a serving of green beans does? Well, in this lecture on carbohydrates, you will learn why carbohydrates don't have to be scary or off limits. You will also learn how carbohydrates impact your body composition and health, why there are certain carbohydrates to eat at certain times of the day, and how exercise fits into this puzzle. In the end, you will have a firm grasp of the ways that carbohydrates that exist and how and why they may impact our body composition differently, and when you can eat a high carbohydrate meal with less fear of storing it as fat. The first thing to keep in mind is that glucose is the preferred fuel source by your brain and your nervous system, as opposed to protein or fat. The body needs glucose for some actions, and it is estimated that we actually make about 50 grams of glucose per day in a process called gluconeogenesis. This amount is quite low, and for people who are physically active and like to exercise, the amount of carbohydrate needed will likely be more. Well, the current acceptable macronutrient distribution range from the Institute of Medicine for carbohydrate is between 45 and 65% of your total calorie intake, with no less than 130 grams of carbohydrate per day to meet our basic physiological needs. And because 1 gram of carbohydrate yields 4 calories, you will need roughly 500 calories per day from carbohydrate just to meet minimal needs. However, more and more research is beginning to accumulate, showing that we may be able to consume far less than 130 grams per day, so long as the dietary fat and protein are also increased in the diet. Fortunately, when you eat very little carbohydrate, you can still function from the production of ketones, which is simply a byproduct of excessive fat breakdown as a result of a low carbohydrate diet. This excess fat breakdown is called ketosis. And recently, ketone use for energy has been the topic of much research and debate. And currently, in 2015, some experts support nutritional ketosis for weight loss and health. Nutritional ketosis is induced when a person is put on a very low carbohydrate diet to encourage the breakdown of excess fat. Other experts recommend the traditional model of a higher carbohydrate, low-fat diet for weight management and health. In any case, the research is quite clear that some glucose is required for life, and even more is likely needed if you decide to become extremely active. However, most scientists agree that the U.S. is an overcarbed nation. They recommend that the steps should be taken to identify what carbohydrates are best to eat at what times during the day to provide the best health and performance benefits and to minimize negative changes to body composition. We know that how active you are, what size you are, and what your specific goals are will dictate how much carbohydrate you should have in your diet. And of the 3 macronutrients, carbohydrates, fats, and proteins, carbohydrates are traditionally thought of as the most important fuel for exercise, particularly during high-intensity exercise like running fast, cycling fast, and lifting heavy weights. A few examples of common carbohydrate-rich foods that you are familiar with are grains, pastas, potatoes, and rice. But carbohydrates are also found in fruits and vegetables. And sugar itself is also a very simple form of carbohydrate, meaning it is rapidly digested and absorbed by your body. These foods are all considered carbohydrates due to their similar chemical structure. Carbohydrates are all composed of carbon, hydrogen, and oxygen atoms in a 1:2:1 ratio. The important point is that the breakdown of these atoms ultimately provides ATP, or the energy needed for all human functions. So, the carbohydrate foods that we eat can range from quite simple, like sugar, to more complex forms like starches and fibers. This ultimately determines how quickly we can digest, absorb, and use them to fuel our activity and store them as fat in our muscles, liver, and fat tissue. We classify carbohydrates by their structure from simplest to most complex. And these include monosaccharides, disaccharides, oligosaccharides, and polysaccharides. In all of these types of carbohydrates, the term saccharide means sugar, from the Greek word saccharum. The prefixes mono, di, oligo, and poly refer to how many sugars are linked together. So mono would be one sugar, di would be two sugar molecules, oligo would be 3 to 9 molecules, and poly would be 10 or more sugar molecules bound together. The simplest form of carbohydrate is the monosaccharide, which consists of only one sugar molecule. You probably have heard of these because they are household names like glucose and fructose, which is derived from fruit sugar. When monosaccharides are combined, a disaccharide is formed, such as sucrose. Fructose and glucose bound together, also known as table sugar. Longer chains of monosaccharides can also combine to form oligosaccharides, which are commonly found in vegetables, and even longer chains called polysaccharides. If you've ever heard of starch, glycogen, or fiber, you are hearing about polysaccharides. The point is that the length of the carbohydrate chain is one factor that determines the rate of carbohydrate breakdown. Obviously, the shorter the chain, the faster this rate becomes. In terms of overall health, you actually want a slower rate of breakdown to avoid any large variations in blood sugar and insulin concentrations. Insulin is one hormone responsible for inhibiting our ability to use fat as a fuel. Another interesting factor that determines the rate of carbohydrate breakdown is the shape of the carbohydrate. So starch, which is a carbohydrate from plant sources, can have two basic forms. Amylose is a straight, long-chain molecule, which is digested slowly. Amylopectin, on the other hand, is a highly branched and rapidly digested molecule due to the increased surface area of the molecule due to the branched structure. And glycogen is also highly branched, and it's in the form of carbohydrate that we store in our bodies. In the context of body composition, we typically just think about carbohydrates that we eat as something that either makes us fat or doesn't. However, we also have to remember that carbohydrates provide us with fuel to ultimately produce energy, especially when we try to exercise at high intensity. Through a process called glycogenolysis, or the breaking apart of glycogen, glucose fuels active muscles during exercise. About 100 grams of glycogen are stored in your liver, with another 300 to 900 grams stored in your skeletal muscles, and just a minor amount circulating in your blood. So if you weigh 150 pounds or 68 kilograms, you will store somewhere around 500 to 1,000 grams of